Right, so let's look at this problem. Two small balls, each of mass 5 grams, are attached to silk threads 50 centimeter long, which are in turn tied to the same point on the ceiling as shown below. Okay. When the balls are given the same charge, the threads hang at 5 degrees to the vertical, as shown below. Okay, we don't have the diagram. What is the magnitude of Q? What are the signs of the two charges? Okay. So here's the diagram, and they have to repel each other, so the signs, the charges have to have the same signs. Negative charges will repel each other and positive charges will repel each other. Okay, Q, oops, no, not even there. I'll write it there. Okay, so here's the diagram. This is 5 degrees. Here's mg, and here's the force of repulsion, and there's the tension in the string. This is L. Okay, what we'll need is we'll need this distance R. This is 5. So R by 2 sine 5 degrees is R by 2 divided by L. So R is 2L sine 5. Okay, so let's find that. L is 50 centimeters, 0.5 meters times sine 5. So the distance between these two guys is 0.087 meters. Okay, 8.7 centimeters. So that's the distance between them. Okay, now so this guy is at rest, and the forces on this guy, there are 3 forces acting on this guy: the tension in the string, this repulsive force, and the weight, his weight. So these 3 forces must add up to 0 because he's at rest. Okay, so on this guy's, so the electrostatic force plus the force of gravity should add up to 0. Okay, and here is our x and y axis. We'll draw it with reference to that. Okay, and so now we'll just equate the components. Okay, now before I do that, let me draw this. This is 5 degrees as well. Okay, so now we'll write down the components. Okay, well, let's do this on this page. Okay, so the x components, yeah, this has an x component and this doesn't have an x component. The x component of this is negative, so t sine phi, that's the sine component. So minus t sine phi is equal to plus Fe equal to 0. Okay, so T equal to let's look at the y component. The y component is, t cosine phi, that's the y component, is balancing mg. Okay. So t cosine phi minus mg equal to 0. Okay, so the x component gives us this and the y component gives us that. Okay, let's equate the two. So kq square sine phi r square equal to mg cosine phi. Okay, and we'll bring sine phi over cosine phi equal to kq square over r square divided by mg. Okay. What is it that we're trying to find? What is the magnitude of Q of the, okay, so Q is mg tan phi r square divided by k to the power half. Yeah, that's what it works out to. Okay. So now we're ready to plug stuff in. Okay, let me copy this. Okay, R was 0.087 meters. What is the mass of these guys? 5 grams. 5 into 10 to the minus 3 kgs. G is 9.81 meters per second square. Tan phi and K is 9 times 10 to the 9. That's the Coulomb's constant. Newton meter square by Coulomb square. All to the power half. Okay, kg meter square is newtons. That cancels with that. There's the meter square that cancels. The Coulomb square comes to the top, and to the power half gives you a Coulomb. Okay, all the units work out good. All right, so let's do the powers of 10 first again. This is 10 minus 5. I'll bring this there. That becomes 10 minus 12. And to the power half, well, actually what I'll do is that's 8.7 times 10 minus 2 square. That's 10 minus 4, 10 minus 12, and 10 minus 4 is 10 minus 16. To the power of half is 10 minus 8. Okay, I hope you all got all of that. And so now it's 8.7 square into 5 into 9.81 into tan phi divided by 9 to the power half. Okay, that's what it works out to. And so let's all right, so what we have found is if you put 60 nanocoulombs on each one of them, they repel each other such that it will hang at an angle of 5 degrees. Okay. And the mass of each of these guys is 5 grams. So that's what we found. Okay. Again, There are three forces acting on each particle. There's the repulsive force, there's the tension, and there's that weight. Okay. That's balancing them. What happens if you, what happens if you increase the charge on each of these guys? What will happen? Everything else is the same. You just increase the charge. This angle will increase. This force will get bigger and this angle will increase. Everything is the same. You make this heavier, what will happen? This angle will decrease. Okay. All right. So that finishes this problem.